Hello everyone, welcome to Coders Camp. We are at 18th day of December LeetCode challenge, and the problem we are going to cover in this video is number at most n given digit set. So the input given here is a set of digits which are in the string format and an integer n, and we have to return the number of possible numbers we can form using the given digits. And it is also said that we can have or form numbers with repeated digits of any times. So let's understand this with an example. So here is a given example in the problem statement. The digits given are 1, 3, 5, and 7, and the limit given is 100. So you have to form the numbers starting from 1 to 100, and you have to return how many numbers you can possibly form using these digits. So let's start with having one digit numbers. So how many one digit numbers you can possibly form from this given number? It is very simple. The given numbers are 1, 3, 5, 7, and those are the possible one digit numbers you can form, in total 4. So how many two-digit numbers you can form? So to count two-digit numbers, you have to start with 1 and combine it with every other number in the given list. So in that case, we can also have repeated numbers. So we have 1, 1, 1, 2, 1, 3, sorry, 1, 3, 1, 5, 1, 7, and same goes with 3, 1, 3, 3, 3, 5, 3, 7, and same goes with 5 and 7. So in total, you have got 16 numbers that can be formed by using the given 4 digits with 2-digit numbers. So how do we actually find it mathematically? So before getting into mathematical solution, how many 3-digit numbers you can form? So you can form 3-digit numbers, but that is not necessary because the given limit is 100, and by calculating the 2-digit numbers you can possibly form, that will cover till 99, and we don't have zeros left, so we don't have to really concentrate on 100. So if we calculate the 1-digit numbers and 2-digit numbers we could form by these digits, we can return the solution. So in total, it is 14 plus 16, 20 digits or 20 numbers you can possibly form within the limit 100 by using these 4 digits. So how do you calculate this mathematically? So easily you can calculate it by doing 4 power n or digits power n. So here they have given 4 numbers in the given digits. So we have to use these 4 digits to calculate the number of numbers we could form possibly using the 1 digit or 2 digit and etc. So to calculate 1-digit numbers, 4 power 1 is 4, and to calculate 2-digit numbers, 4 square is uh, 16, and to calculate 3-digit numbers, 4 cube, and so on till how many digits we can possibly form. For example, if we have given 1000 as the limit, then we have to calculate 4 power 3 and add it to these numbers. And if we have given 10,000 as the limit, and it goes on and etc. So these are the happy path case that we can easily find these numbers and how many possible numbers you can form by using these digits. So what if the numbers given are some 536? So in that case, you can simply just calculate 4 power n and get the result. So you have to, or you can simply calculate 4 power 4 and do it and calculate, because the number is somewhere in the middle. So you have to really try to get the numbers that could possibly within the limit 536. So that is what making this problem a little harder. So let's understand how are we going to handle these kind of cases here. So now consider the limit n is equal to 5367. So in this case, you first will find the limit from 1 to 100 with 4 power 1 and 4 power 2. And with the limit 1000, you'll go for 4 power 3. But this is something from 1000 to 5367. So in this case, how do you find it? So first, let us start with keeping 1 as a constant, and the 3 numbers can be anything or repetitive. So in that case, you again have 4 digits because 1 also can be repetitive. And so for example, if the number is 1 and the rest of the 3 digits are x, x, x. So in this case, these x's can be any of these 4 given digits. So again, you have to form a 3-digit number and append it with 1. So keeping 1 as constant, you would have 4 cube or 4 power n to construct the rest of the numbers. So if we have to form a 4-digit number, then 1 is constant. We clearly know the first digit is always going to be 1, and the rest of the numbers you could possibly form would be 4 cube. So same goes with 2, keeping 2 as constant, but the number 2 is not given. So the next number is 3. So keeping 3 as constant, the rest of the number xxx can be anything with 4 power 3. So the next number is 4, but we don't have 4 here. So the next number is 5. So here we simply can't calculate keeping 5 as a constant, and the rest of the numbers can be xxx, because the limit is not 5999, but the limit is 5367. So you have to be very particular about fixing these digits. So this can be handled by keeping 5 as constant, and the first x could be less than what is there in the second place in this position. So the position is having 3. So this second position would possibly have 1 or 3, because we are given only 1 and 3, which is less than or equal to this number. So in this case, again, you can handle 1 very easily, because the rest of the numbers are going to be 2x's. So this count will be given by 4 square, or the number of digits given power n. So here comes again 3. So you can't simply keep the rest as xx, because you have given only 6 and 7. So again, this third and fourth number will be fixed based on the values at that position. So now the position is having 6. So the numbers which are equal or less than 6 could be added in this place. So 5, 3, what are the numbers that are there in the given digits which are less than or equal to 6, which are 1. So it could be 1x, and 5, 3, 3x, and 5, 3, 5x, and the other number is 7, which is greater than 6, so we can't fix it. So this x can be again 4 other digits, 1, 3, 5, 7, and this x can be again 4 digits, and this x can be again 4 digits. So this will give you 4, 4, and 4. So we have covered all the cases for this number. So solution of this problem would be calculating the happy path numbers 4 power 1, 2, and 3 till 1000. And from 1000 to 5300, it will be 4 cube plus 4 cube plus all this calculations. So sum of all this would give you the results. So this is pretty simple. All you have to do is calculate the possible numbers you can form mathematically by keeping the numbers as constant and calculating the values for rest of the numbers and do an addition. So we are going for a DP solution where we are going to maintain a DP array of number of digits given. So there are 4 digits and we'll be having 4 cells. From the last digit, we are going to put the values and keep adding it to the previous cell. And so these cells will be having the values of these kind of calculations, that is the special cases. And finally, DP of 0 would be having all the addition plus these happy path values. That is, if we have to form a 4-digit number, so we'd be calculating 4 power 1, 4 power 2, and 4 power 3. If we have to calculate a 5-digit number, then simply we'll add all this plus 4 power 4, and that will be calculated and stored in DP of 0, and this will be returned as our output. So hope you're understanding this logic, and this algorithm is going to work in big O of log n time, because for each digit we are going to calculate the possible permutation of the count of numbers. Keeping the given digits are constant throughout the algorithm, the constants can be omitted, and log n time is because every time we are going to shorten the size of numbers we are going to calculate the size for, because it is going to start with if it is a 4-digit number limit, then it is going to start with 3 digits and then shorten to 2 digits and then shorten to 1 digit and etc. So yes, let's get into the code now. So here is the code for this problem. So first we are converting all the numbers to string, because the given digits are in the form of string. So if we convert the integer to string or the given digits to integer, to keep everything in one form, it will be easy for us to compare. So we are first converting the given n to string, and then we are taking k is equal to string dot length. But this k is nothing but the 4 we have used. So this k is going to be the constant which we're going to use for our calculations in all the places. And as I said, we are going to have a DP array to store the calculations and calculate it. And we are declaring DP of k is equal to 1. So which is nothing but we are going to start the very last position with the value 1. and we are iterating it from the reverse to handle the special cases first and then going forward for the happy path cases. So first we are converting the given digits in n to integer. So and we are taking the each digits to compare with that integer and calculate the special cases first. To calculate the special cases, we are comparing whether the value at d is less than the given digit in the n. So which means if it is less than, then we are going to keep that digit as constant and do digit dot length power k minus I minus 1. This k minus I minus 1 is nothing but if we keep some 5 as constant, and the rest of the x is going to be total length minus I minus 1. So that is the rest of the characters we are going to calculate for. That is 4 power 3. So yes, otherwise if the digits are equal, then we just have to take the previous calculated value and add it to the same value, because we have calculated for that digit already. So we are just simply taking that value and adding it to the next value. And yeah, that's it. This is a simpler calculation for calculating if the digits are less and equal. If the digits are more, we are not going to consider that at all, because as I said, we have to have our digits only within the limit. We cannot exceed the limit. So we are not having a case for the value greater than the digit at all. So once all that is done, we are going to put a simple loop to calculate the happy path values, which is nothing but the digit dot length comma I every time. And we are finally going to return our result in dp of 0. So hope you're understanding this problem. If not, try it yourself or try to print the value and understand it. So let's run and try. Yes, so let's submit. Yes, the solution has been accepted and runs in 0 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.